When I plug in 1, negative 1/3 minus 3/2 plus 4. That's it, not the 0. Now when I plug in 3, 27 over 3, again 9. Again, I have 27 over 2 minus 12. But minus, be very careful when you plug in 1. 1/3 plus 3/2 and minus 4. Yeah, this is cumbersome, but we have to do it. So this is 13. 13 minus 12 is 1. Negative 1/3. This is positive. 27 minus 3 is 24. Divided by 2 is 12. And we'll check in a minute, right? So let me see if I counted everything here. So this is 13 minus 12 is 1. I copied this. 24 over 2 is indeed 12. Minus 1/3, minus 3/2, and plus 4. Let's see. 4 plus 1 is 5, plus 12 is 17. Minus 2/3 and minus 3/2. So the LCD has to be 6, and 2 here and 3 here. I think it's 102, minus 4, minus 9. I think so, minus 4, minus 9. Okay, so this is 102 minus 13 over 6. So this is 89 over 6. Very easy to check. Where are you guys? I lost you. Okay. So 89 divided by 6 is whatever. And then we had the integral from 0 to 1 from negative x squared minus 3x plus 4, of course dx, as if you can put in there dy or z or something. I don't know why they it doesn't come up directly, but anyway, from 1 to 3. And this time we have t squared plus 3t minus 4. T squared plus 3t minus 4 dx. When I click enter, I have to get this. If I don't get this, then I have an error and I have to go back and find my error. Okay. Since there is no error, this is it. So the total distance, and please remember the measurement unit, meters. I've seen meters per second, I've seen meters per second squared. No, this is the total distance, it's in meters. Good. A lot of work on this problem. Anything else you would like to work on? So this was the total distance. So we still have the anti-differentiation or anti-derivatives and properties of definite integrals.
I think probably properties.
Now, if I remember correctly, I think that this total distance was due tomorrow, so I have to make up another problem for you for tomorrow, because we already worked on it. I think this was due tomorrow. Yes, what did you say? So if you did not submit this already, if you did, then you get credit for it. You don't have to do another. But if you did not submit this, then I have to select a different problem. So we want to the properties of definite integrals?
Sure.
Okay, very good. So I am Looking through the book, ebook. So these are, I think, in 5.3 or 5.2 with the definite, with the fundamental theorem of calculus. No, they are with the properties of definite integral. I think it's 5.2. So does this mean that I'm logged out? No. Okay, I'm not logged out. Hopefully I'm not logged out. Okay. Oops, my computer is running out of juice. Okay. That's it, 5.2. Okay, I remember doing 67. Careful with 68 because, yes, we can evaluate this, but this is not what we're asked to do. We're not asked to evaluate. We're only asked to show that this integral is between these two numbers.
Will we have a problem like this?
Yeah, these are the properties of the definite integral.
Okay. Did we do 66?
We did 67. We can do 66. I remember doing 67. Let's look at 66. So 60 is the integral from 0 to 1, the square root of 1 plus x squared dx, less than or equal to the integral from 0 to 1, 1 plus x dx. Perfect. Very good pick. Okay. So remember, like with this quiz theorem, we have to start with x. Where is x in this problem?
Underneath the square root.
Right. But we're talking about values. When we put something like this, we're talking about values, not function. So the starting point is with values of x.
0 to 1?
Of course, yes. So we are slowly and surely trying to build this function, and we'll see, we'll discuss that. So notice what happens here. We are discussing basically the values of the square root, but they both have square root. So we are really comparing 1 plus x squared to 1 plus x. Basically, if you want to say, we are comparing x squared to x, because then I can add 1 to both sides. So this is the core. The square root is the same in both. The 1 is the same in both. So basically, we're comparing these two quantities first. And we discussed this last time with the 67. So on the interval 0 to 1, which of these quantities, this or this, is smaller? So do I put this symbol or I put this symbol? That's the only discussion here. If I have a number between 0 and 1, which number will be smaller? The squared one or the plain one?
The squared.
Yes, smaller or bigger?
Smaller.
Exactly. Which is not the same if I have a number from 1 to infinity, right? The squared one will be bigger. But when we talk about 0 to 1, x squared is definitely smaller than x. And now slowly but surely I will build my functions. If that's the case, now I add 1 to both sides. Nothing should happen because I'm adding 1 to both sides. Since they are positive numbers, everything is positive, then the square root can be applied. And we have the definite integrals have a property. If a function is lower than a function, then the integral from this one must be lower than the integral of this one. And this is done. That's all we're asked to find. So we're stating a property of the definite integrals that says this. If f of x is less than or equal to g of x on an interval a comma b, then the integral from a to b from f of x dx must be definitely smaller than the integral. We're not asked to evaluate anything. We're just asked to show that this integral will be a smaller number than this one. Who cares what the numbers will be? No one. We only have to show that this is a number that is smaller than this one. And we quoted the property. And this is it. The problem is solved. We don't have to do anything else. So we only discussed starting with x, if x is between 0 and 1, because that's what we have. The 0, 1 come from here. So then we analyze the fact that we have x squared and x. Well, on this interval, x squared must be smaller than or equal to x. Guaranteed. Then I'm adding 1 to both sides. Then I'm taking the square root because they are both positive quantities. Otherwise, I can't take the square root in an inequality or apply the square root in an inequality like that. No. But they're both positive. So then the square root of this must be smaller than the square root of this. And then the property says that if a function is smaller than another, the integral, and positive, the integral of this is smaller than the integral of that. Any questions? Any questions? Okay. So this was one of the properties of a definite integral. So what else is left from here is the anti-differentiation. Would you like to choose a problem? Let me show them to you. They are from 4.9. I never know how to, once I'm in a chapter, how do I go back? How do I go back to a different chapter? To click on a different chapter.
It's the X button, I think, in that corner. That one. And then I think there might be another x button behind that.
Excellent. Thank you so much. Awesome. Thank you, thank you, thank you. What I would do, I would go to full book or start from scratch in the ebook. But that's perfect. Thank you. I never tried that. Thank you so much. Okay, in 4.9, okay. So we may be given a function, and then we have to use the notation uppercase f, or we may be given the derivative, and then we have to stick with the notation f of x. So would you like to choose, or I will?
Yeah, can you scroll back up? There was one, I think it was 38, maybe? No, not 38. 36.
36, perfect. Let's take a look. I'm on page 12, and we want 36. And in 36, we have the third derivative of t, the square root of t minus 2 cosine t. Perfect. Since we are given lowercase f, we stick with the notation. If we are given f of x, then we have to use the notation uppercase f of x, but if we are given the third derivative, we have to continue with the second, and then the first, and then the function. Perfect. So I have to find the second derivative first. And of course, I will change this into t to 1/2. So t to 1/2 will be 3/3 divided by 3/2 minus 2 sine t plus, I'm going to use c1 this time. So the derivative of this is this, the derivative of this is this, and the derivative of c1 is 0. I will flip. So this is 2/3 t to 3/2 minus 2 sine t plus c1. Now we want to find f prime of t. So we have 2/3 t to 3/2 plus 1, which is 5/2, of course divided by 5/2, plus 2 cosine t, because 2 cosine t prime is negative 2 sine t, plus c1t plus c2. Flip. So we have 4/15 t to 5/2 plus 2 cosine t plus c1t plus c2. And finally, we have f of t. 4/15 t to 5/2 plus 1, of course divided by exactly the same number, plus 2 sine t plus c1t squared over 2 plus c2t plus c3. So I will continue because I need to simplify one more time. 8 divided by, I think it's 105, 5 and 3, yes, t to 7/2 plus 2 sine t plus c1t squared over 2 plus c2t plus c3. And this is the most general antiderivative of the given function.